In this video, we're going to do a full paper 4 walkthrough from this past exam that happened just back a few months ago for the May and June 2024 examination. So this exam covers a lot of wonderful things. It's a great, well-rounded exam to make sure you're ready for a lot of things. So let's go ahead and take a look at question 1, which is a prime example. A program needs to take integer numbers as input. So right away, I know we're going to be using an array, and it also tells me we're going to be using a 1D array. Then it says to sort the numbers. So every year as we go through the course, I always tell my students, you got to know how to do a bubble sort, and you need to know how to do an insertion sort. Don't just prepare for one, prepare for both, because they could ask us to do one or the other, and then search for a specific number. This could be a linear search. This could be a binary search. If they're having us do a binary search, we have to know how to do a standard binary search that is not recursive, but also at the same time knowing how to do a recursive binary search, because they could ask us to do either one. We're not interested in getting most of the points. We're interested in getting all the points and going for that A prime. So let's go ahead and take a look at this and see what we're going to be doing. So part A, the integer numbers will be stored in the global 1D array. So right around there, I want to know right away that it's a global 1D array. I want to pause for a moment and remember that. Because if I forget that, I make it part of my main program, a local 1D array, I'm going to lose this one mark that I could get here. So they want the integer numbers to create a global 1D array. It's going to be called data stored with space for up to 20 integers. So that doesn't mean I'm going to use every index. I'm just going to use up to 20 integers. So 20 whole numbers. The global variable number items stores the quantity of items the array contains. Write program code to declare data stored and number items. So let's swing over to VB and pick up this 1 point to kick off this paper 4 exam. Remember, your global variables always go outside any procedure or function. So here we're going to do dim data stored. Now something I'm going to focus on this year with my students is forcing them to use index 0. Do you have to use index 0? No, you can change this 19 to 20 and admit index 0, but this year, because I'm going to be making my students work with index 0 just to further sharpen their array skills, I'm going to go with index 0 for this video. The next one we need is the next variable they give us, which was number items. That is also an integer, not an array. So I have my global variables, data stored, the 1D array as an integer, my number items as an integer. We're now ready to move on to the next part after we just picked up that 1 point. All right, the procedure initialize procedure. I want to stop right there and I want to pause and remind myself, hey, I'm going to be writing a sub, not a function. Nothing's going to be returned here. So it prompts the user to input the quantity of numbers the user would like to enter. Now remember, they can enter up to 20 numbers. It reads the input and validates that it's between 1 and 20 inclusive. Now inclusive means 1 is acceptable as well as 20. So 1's going to be the minimum number, 20 is going to be the maximum number. Prompts the user to input each number and stores each number in data stored. That's our 1D array. Write program code for the procedure initialize. So let's swing over to VB and let's get that coded out. So here's our procedure initialize. It doesn't mention any parameters, so we don't write anything inside the parentheses. The first thing I'm going to do is number amount as integer. I need to know what max index I'm going to. We'll talk more about that in a minute. So I'm going to do console.writeLine. I'm going to give them a prompt because we have to prompt the user for how many numbers do you want to enter? And then we're going to do number amount equals console.readline. Now you may be saying we got to put that in a loop, and you're right. One of the best things to do to make it a little easier is actually write out what your loop will be doing. Now we know this needs to loop until they enter a minimum of 1 or a maximum of 20. But the question we need to ask ourselves is, what is the most appropriate loop to use? Well, it's not going to be a for loop because we don't know how many times the loop is going to run. Do we use preconditional or do we use postconditional? Preconditional loop is when your loop may not ever run. because we know our loop's going to run at least one time, because we have to ask them, how many numbers do you want to enter? It's best to use a post-conditional loop. So a for loop, when you know how many times it's going to run, preconditional when it may not run at all, post-conditional when it will run at least one time. So I'm going to put my do right here at the top. What are we doing? We're doing this, and we're looping until our number amount is greater than or equal to 1 and number amount is less than or equal to 20. Both of those conditions need to be true. If both of those conditions are not met, then we're going to loop around and we're going to ask them again. Now, once they enter how many numbers they want to enter, I now know how many times the next loop needs to run. And the next loop is going to be them entering any number they want. So I'm going to do for I equals 0, 2, and you may be thinking it's number amount, but not quite. It's going to be number amount minus 1. But why is it going to be number amount minus 1? How did we get there? Now remember, I'm using index 0 in my array. If I want to enter 3 numbers, I'm going to use index 0 for my first number, index 1 for my second number, and index 2 for my third number. So if I go to number amount and I want to enter 3 numbers, this is going to use index 0, 1, 2, and 3. I don't want to use index 3. I want to use index 0, 1, and 2 when I'm entering 3 numbers. So that's why it's number amount minus 1. The next thing I need to do is tell them to enter a number. So I'm going to do console.writeLine, enter a number, and then what I'm going to do is I'm going to store that in data stored. I'm going to do data stored I. What does I stand for in a for loop? Remember, I in a for loop stands for index. We're going to start at index 0, and we're going to keep running until we reach the index for the number of items they want to enter minus 1. We're also going to do number items plus equals 1. And just like, let me get rid of these extra lines. And just like that, we're done with the procedure initialize, and we just picked up 5 more marks on this paper 4 exam. Let's swing back and take a look at the next part of the question. Okay, part C, the main program stores 0 in number items, calls initialize, and then outputs the contents of data stored. Then they want us to test the program by entering 30. Now, when we enter 30, we need to predict what our program should do. We know 30 is not between 1 and 20 inclusive, so we know it should loop again and ask us to enter, or ask us how many numbers are we entering again. If we enter 5, we then should be able to input and store the number 3, 9, 4, 1, and 2 inside our 1D array. So we're going to take 0, put it in number items, 1 line of code, call initialize, 1 line of code, and then output the contents of data stored, which we're going to use a for loop because we know how many times it's going to run. So let's switch over to VB and let's code this out. So the main program, that means sub main. The first thing we're going to do is we're going to do number of items equals 0. It's very important we do that before we call the procedure initialize. How do we call a procedure? Well, how do you call your friends? How do you get their attention? You call them by their name. If we want to get this sub's attention, we need to call it by its name, which is initialize. Then the next thing we need to do is we need to output this array. So I'm going to do for I equals, I'm going to start at index 0, and I'm going to go to number items minus 1. That is because if I know I have 5 items, I know that it's going to be stored in index 0, index 1, index 2, index 3, and index 4. If you are omitting index 0 and you're starting at index 1, you're not going to do number items minus 1. Because I'm using index 0, that counts as an index. That's why I want to do number items minus 1. I don't want any blanks showing up here. So what am I going to do? Console.writeLine. And all I'm going to do is I'm going to do data stored I. Just like that, it will output the array up to the last index that we use. The next thing we need to do is run our program and enter that data. How many numbers do you want to enter? Well, they want us to type in 30. Now we know 30 should not work, and it should say, how many numbers do you want to enter again? And it does. Perfect. How many numbers do you want to enter? They told us they want us to enter 5. 5 should be accepted. Perfect, it is. Now we actually enter the numbers, and the numbers are going to be 3, 9, 4, 1, and 2. The next thing we should see is that output those numbers. So it does 3, 9, 4, 1, 2. So we see the numbers are outputted exactly as they're supposed to be. So let's go ahead and move on to the next part of the question. The procedure, and that's very important, we want to know this is not a function, but it's going to be a sub. The procedure bubble sort uses a bubble sort to sort the data in data stored into ascending numerical order. So the idea with the bubble sort is we start at the beginning and we look to see if the first index is greater than the next index to it. If it is, they need to swap. So in the numbers of entering 3, 9, 4, 1, 2, we're going to see if 3 is greater than 9. 3 is not greater than 9, no swaps take place. So we move to the next index, which is index 1, which will be the 9. We check to see if 9 is greater than the index next to it, which is 4. 9 is greater than 4, so we are going to swap those indexes. Then we see if 9 is greater than 1. It is. We swap 9 and 1. Then we check to see if 9 is greater than 2. It is, so we swap that. The idea of the bubble sort is the largest data, when you're going in ascending order, the largest item bubbles to the top. Now you have to remember, with a bubble sort, you are not checking the item that just bubbled all the way to the top. The last item you are checking is the item previous to that. So I'll explain that again when we do our bubble sort loop. Then it says write program code to amend the main program. So we're going to call bubble sort. Then we're going to run another for loop and output the contents, which it should be sorted. So let's swing over to VB and code out that bubble sort. I have my procedure bubble sort. Now I've commented in the numbers 3, 9, 4, 1, and 2, which is what we just used. And I imagine we're going to be using those numbers again. So I'm going to walk through how the bubble sort works in case you're unfamiliar with it. The first thing I'm going to need is I'm going to do dim as integer. Now I'm going to set in equal to the data stored dot length -1. That way, if they want us to enter more numbers, we can update in, and this we won't have to go back and change our code just in case they change it. Now, I also need a Boolean value, no more swaps as Boolean. Now I'm going to set no more swaps equal to false, and I'm going to do that inside my do loop. So I'm going to do loop until, and we're going to keep looping until no more swaps equals true. Inside here, I'm going to do my bubble sort. Before I start my bubble sort, I want to say no more swaps equals true, because maybe the array is already sorted, but I have to run a for loop and check each index and the index next to it to see if swaps need to take place. So I'm going to do for I equals, I'm going to start in index 0, and I'm going to go to n -1. Now let's talk about why do we need to go to n -1 if n already equals data stored dot length -1. Okay, so we know that n is going to be 4 because I'm using index 0. So I have index 0, which holds 3, index 1, which holds 9, index 2, which holds 4, index 3, which holds 1, and index 4, which holds the number 2. But why am I going to 0 to 3? Why am I doing that? Why am I only going to the 1? That's because when we get to index 3, we're going to be comparing that to the index next to it, which is going to be I plus 1. So we're going to be comparing index 3 and 4. If I let my I go all the way to 4, when I type in my code and compare index 4 to index I plus 1, that's 5. I know there's nothing there. That's why we don't need to do that, because there's not going to be anything in that index. So we only need to go to n 1. And if that's a little unclear, I'll clear it up again in a minute. So all we're going to do is we're going to do if data stored I. So we're checking to see if 3 is greater than data stored I plus 1. That's what we're doing. If that is true, we need to swap them. Is 3 greater than 9? No, it's not. Oh, I'm going to need another variable. We're going to need temp, because we got to store that data if there is a swap taking place. So temp, if we need to swap something, then what we have to do is we need to store data stored I. Then we can overwrite data stored I with data stored I plus 1. And then in data stored I plus 1, we can put in temp. That is the bubble sort. Now, did we just swap? We sure did. So no more swaps equals false, because we just made a swap. So there isn't no more swaps. So no more swaps equals false, because there are still swaps that we are handling. This no more swaps equals true once we exit the for loop. As long as there's no swaps that take place, then it'll stay true and we'll exit that loop. Now, the idea of a bubble sort is once it bubbles all the way to the top, you don't need to check it again, which means you need to decrement in by 1. So let's walk through this for loop the first time. So no more swaps equals true for I equals 0 to n minus 1. So we're going from 0 to 3, because remember, 3 plus 1 equals 4. I know that's my max index. If I let this for loop go to 4, I'm comparing index 4, which is whatever's here in index 4, to 4 plus 1, which is 5. There's nothing in index 5. There's no need to do that. So that's why it's only going to 3. So I look to see, is 3 greater than 9? No, it's not. So I hit the next, go back around. Now we're looking at the next item, 9. Is 9 greater than 4? Yes, it is. So now a swap takes place. So now it's 3, 4, 9, 1, 2. So we take data stored I, which is the 9. We put that in temp. Then data stored I, what are we putting in there? We're putting the next index, which is 4. We're putting that where 9 was, and then we're taking the 9 and swapping it where the 4 was. So that's how we have 3, 4, 9, 1, 2. We go to the next iteration of I. So we were at I equals 1. We're now at I equals 2. What's in index 2? That is 9. Is 9 greater than 1? Yes, it is. So we have a swap. So now it looks 3, 4, 1, 9, 2. We go for the last iteration of the for loop because now I is equal to 0, 1, 2, 3. We are not going to index 4. We look to see is index 3, data stored 3, which is 9, is that greater than 3 plus 1? Well, what's in index 3 plus 1? Well, that's index 4, which is 2. 9 is greater than 2. We take 9, we put it in temp, we take the 2, we put it where the 9 is, then we take the 9 and put it where the 2 was. No more swaps equals false. We go back around and we start again. So now the last time this runs, it's going to be 3, 4, 1, 2, 9. The 9 will never ever be compared again because it just bubbled to the top. That is why we decrement in by 1. We don't need to go all the way. We don't need to check index 4. The max we need to go to is index 3. The downside of a bubble sort is every time it gets sorted, you have to start again from the beginning. That's why we always start at index 0. So all we need to do now is we need to call this bubble sort and we need to output it. So we're going to go up here to submain. We're going to call it by its name, bubble sort. Now what I'm going to do is, and you can take this line out after you test it. So I'm going to say after sorting. And I can leave it in there. Cambridge isn't going to take points off, but it allows it much easier to read. And all I'm going to do is I can copy and paste this code right here, or I can type it again. It doesn't matter because we should see it being sorted. So let's go ahead, let's run this code and make sure when we enter that data, it is sorted. We're running our procedure bubble sort. 39412, that was the test data that Cambridge gave us last time. Let's say this is our data stored array. We need to be able to write a bubble sort. The idea of a bubble sort is that the largest sets of numbers, because we're writing them in ascending order, bubble their way to the top. So we need to write an algorithm that will allow us to do it. I'm going to need some variables first though. The first one is temp as integer. We'll explain what all these do in just a moment. I also need array sorted as Boolean. That's going to determine whether or not we exit the nested loop that we're going to have here. The last one I need is in as integer. My in stands for the max index that I'm going to have. Because I have included index 0, I need to set into number items -1. You may be saying, why would you do that? Well, remember, we have 5 items, but our max index, which is going to be represented by n, only goes to index 4. 3 is in index 0, 9 is in index 1, 4 is in index 2, 1 is in index 3, 2 is in index 4. We're going to create a post-conditional loop. Our bubble sort is going to loop until array sorted equals true. Once the array is sorted, we know we're done. But I need to set array sorted before we enter this for loop. I need to set it equal to false. Otherwise, it's going to exit right after the first time it is done. So what we're going to do here is we're going to do a for loop for I equals 0 because I need to check my first index, which is 0, and I'm going to run to n minus 1. Now you might be saying, whoa, why are we doing n minus 1? Why would you not check all the values? Well, we're comparing the current item to the next item. For example, I'm going to compare this 3 and this 9, the 9 and the 4. 9 is greater than 4, so they're going to swap. Then I'm going to compare the 9 to the 1. 9 is greater than 1, so we swap. When I get to this third index, I need to compare it to the next index by using I plus 1. That will allow the 9 and the 2 to be compared. If I allow us to go all the way to the last index, index 4, the 2 has nothing to compare itself to on the right after it. That's why we want to go that far. We'll also, once the 9 bubbles all its way to the top, we've already compared it. We don't need to compare it again, so we'll need to update in. And we'll take a look at that in just a moment. So all we're going to do is we're going to do if data stored I, if that is greater, we're looking to see is 3 greater than 9. So that's going to be, let me put it right where it goes, data stored I plus 1. We are checking to see if the current item is greater than the next item. If it is, I need to swap them. It needs to bubble all the way to the top. So the first thing I'm going to do is I'm going to store data stored I. I do not want to lose that piece of data. So let's take a look here. Is 3 greater than 9? No, it's not. This if statement never runs. Is 9 greater than 4? Yes, it is. So what we're going to do is we're going to take this 9, we're going to put it in temp. That way we do not lose it. Then we're going to do data stored I. What are we putting where the 9 was? Well, that's going to be data stored I plus 1. We are taking that 4 and we're putting it on the current index where 9 is. Now what we need to do is we need to put that 9 where the 4 was. So that means data stored I plus 1. What is that going to be? That is going to be temp. And those 3 lines allow my bubble sort to work. Now what we need to do is, because we just made a switch, our array sorted equals false. So this actually needs to be array sorted equals true. this needs to be array sorted equals true, because if the array sorted never equals false, then we can exit the loop. So this array sorted equals true. Here, we know it's not sorted because we just made a switch. Now what we need to do is we need to update in. Because 9 has bubbled all the way to the top, we don't need to compare it again. If we just leave this as n minus 1, yes, it's still going to sort, but it's not an actual bubble sort because you're comparing items that you've already compared. So what we need to do is we need to update in, and we do it right after this for loop. So we do in minus equals 1. It's going to decrement it by 1. So just like that, that is our bubble sort. Now the next thing it wanted us to do was to call the bubble sort and then output it after it's been sorted. So let's go back to our submain. So we need to call our bubble sort. So we call bubble sort. Now what I'm going to do is, I'm going to add in a line here after calling the bubble sort. And that's so when I'm looking at those numbers that we're going to enter, I know that it'll just be easier to read and see that they are sorted. Then all I'm going to do is I'm going to copy and paste this for loop, because now I'm outputting that data stored array using the items that we use. Let's go ahead and run our program and make sure that the data has become sorted. And it's time to test our bubble sort, so we're going to enter the number 3, 9, 4, 1. Okay, 149. What's going on here? Number of items is 1. Let's try this again, because we want it to run 5. Oh, how many numbers do you want to enter? I want to enter 5 numbers. Okay, now we can do it. It helps if I read the directions. It's my prompt. I wrote it, and I didn't even read it. All right, let's try this again. Okay, 3, 9, 4, 1, 2. And we can see here before it is sorted, it's 39412, which matches our previous output. And then after we call the bubble sort, 1, 2, 3, 4, 9, we can see the numbers have been sorted indeed. So let's go ahead and take a look at the next part of the question and continue earning points on this paper 4 exam. All right, the function binary search, and I stop right there. I notice it's a function. I know it's going to be returning a value. So I'm not going to write a sub. I'm going to write a function. I'm going to call it binary search. Takes the integer parameter data to find. So I know it has a parameter data to find to search for in the array. Performs an iterative binary search. So we're not doing a recursive binary search. A standard binary search on the array data stored returns the index. So we're doing a regular binary search and we're returning the index where data defined is found. We are not returning the value itself. So if we're searching for the number 9 inside our data stored array, it's not going to return the value of 9. It's going to return the index where 9 is found. If data to find is not found, the function returns -1. So we are returning an integer here, -1, if it's not found. Write program code for the iterative function binary search, then write program code to amend the main program to take a number as input from the user. We can do that very easily. Call binary search with the number input, and that is the that's going to go down to the parameter data to find inside the function. Output the value returned. Remember, what are we outputting? The index of where the item we are looking for is found. So from the function call as its parameter, so we're outputting the value returned, and that's going to be the index of where it is found. So let's switch over to VB and let's pick up these 9 points on this Cambridge exam. We have our function binary search. Before we start coding out the variables, we need to handle this parameter. By val, data to find. That's the name they gave us. That's an integer. What is this function going to return? It's going to return an integer. I've indicated that here in my function header. There are some variables we're going to need. We're going to need LB as integer. What does LB stand for? That's my lower bound. I also need to know my upper bound as an integer, and I also need mid as integer. So I have my lower bound, my upper bound, and mid, which is the middle. Now, my lower bound is going to be 0. My upper bound, don't be too hasty to write 4 because you may think it's 4, but only in the test data they gave us. This should work for any number of items that the user wants to enter between 1 and 20 inclusive. So how do I know? What if they enter 10 items? What if they enter 7? What if they enter 15? How am I going to know what my upper bound is? Well, don't remember, we have number items. I'm going to -1 as my upper bound because what is my max index in the array of the data they gave us? It was 4. But what if they enter 10 items? My max index would be 9. My number of items -1 will handle all of that perfectly. Then I'm going to do a do while loop. So I'm going to come down here. I'm going to make my loop do while what? I want to do this while lower bound is less than or equal to my upper bound. This will keep running. If I exit this loop, then what I'm going to do is I'm going to return -1 because that means it was never found. Now, there are 3 possibilities when I'm doing my binary search. The first one is that the item is found, but how do I know where I'm starting? Well, we need to give mid a value. Mid is going to be our lower bound plus our upper bound, and what we want to do is we want to do integer division. This is not integer division. This is integer division. So you want to make sure you flip that divide sign around because you want to be using the right integer division. The next thing we need to do is we need to see, is the item we're looking for there? So we're going to, whoops. Now, when that happens, you hit Control Z and that will undo everything. So I just deleted everything by mistake. Control Z will be a lifesaver for you. If data to find, if that is equal to data stored mid, then we have found it. All we're going to do is we're going to return mid because that's going to hold the index of where the item is found. Because remember, we're not returning the item, we're returning the index of where the item is found. Now, that's one possibility. Another possibility is that data to find is earlier on in the array than where we currently are, which is data stored mid. If that is happening, I don't need to check the rest to the right of the array where everything has been sorted. So the entire array has been sorted, but if I'm looking in the middle and the item is less than where I am, I know it's definitely not going to be on the right. So I want to update my upper bound, and that's going to be mid -1. Now there's another possibility, and that is where the item is greater than what we have found. I can simply use an else statement, or you can use else if, it's up to you, but my lower bound is going to be mid +1. So here, right outside of, well, if we find it, we don't need to return anything here because that will exit the function. Right here, this will return mid. And if it doesn't get found, once lower bound is not less than or equal to upper bound, we're going to return -1. So let's go ahead and run this and let's make sure it works. That's also part of the question. So let's go back to submain, call it, and then let's run some test data. All right, we're back in submain. Now, anytime you write a binary search or even a linear search, or a bubble sort or insertion sort on your exam, you definitely want to test it out to make sure it works. Even though they haven't given us test data, they did give us test data earlier, and we can use that to make sure it works. So we're going to enter those numbers again, but the first thing we need to do is we need a variable. So I'm going to go right up here at the top. Do you have to put your variable at the top? Absolutely not. I like to put it at the top because that's where I always put my variables. So I'm going to do dim num as integer. Then I'm going to ask them to enter a number. So console.writeLine, enter a number to search the array. So we're looking for a number that's in the array. Then I'm simply going to do num equals console.readLine. Then what I'm going to do is I'm going to call the binary search. Now, if you do binary search num, this will run. You're not going to get an output though. So what we want to do is do console.writeLine binary search num. What this will do is, because remember, binary search is going to return the index of where an item is found, or -1 if the item is not found. So we want to output that number. So let's go ahead, let's save. Let's run this program and then we'll be able to take a look at it. So we're going to run our program, enter the test data, and see if we can find it. How many numbers do you want to enter? So we're going to say 5. We're going to enter that same set of numbers again. So 3, 9, 4, 1, 2. We see after it has been sorted. Now, we're going to look for number 3, which is in the middle of the array. It should return the value of 2. So I'm looking for 3. It is found in index 2. Now, something else you want to do is you want to test those other numbers. So I'm actually going to test 1, 2, 4, and 9 as well. It only takes a few minutes to do that. So I want to enter 5 numbers. I want to do 3, 9, 4, 1, 2. I already looked for 3. I'm going to look for 1. That is found in index 0. Perfect. Because it's only going to take a few minutes to test. And you want to make sure it's working so you get full points on that exam. Is it tedious? Yeah, probably. But you have 2.5 hours, a little bit of flex time, not a lot. And then 2 is index 1. Perfect. Looking good here. 5 numbers. But as you go through the exam, you want to make sure your stuff's working, because what you don't want to do is get to the end of the question, use their test data they give you, and then realize you made a simple error, because now you got to go back and change multiple things. It's easier to change things, after a little while, or right away, rather than waiting a little while. Number 4 is in index 0, 1, 2, 3. So this should return 3. It does. Perfect. The last one we need to check is 9, and that should return index 4. And then we'll know that our binary search is working. So enter a number to search the array. I'm looking for number 9. And that returns index 4. It's working perfectly. All we need to do now is go back to question 1 and continue chipping away at it. So this question right here is for the bubble sort. I actually got it mixed up with the binary search question. This question comes before the binary search. This is part of the bubble sort, and we said they didn't give us test data. That's because I had it out of order, but that's fine because we still tested it with that, and we saw that the sort does work. So this question was supposed to show up before this question. On the exam, you don't have to worry about that because they will be in order. So we wrote out binary search. We're now ready for the last part of the question, which says test your program twice with the following inputs. 1 or 5, because we want to enter 5 numbers. Then they want us to enter 1, 6, 2, 8, 10. They want us to search for 2, then enter that again, 1, 6, 2, 8, 10, 7. So when we look at test 1, we need to ask ourselves, okay, what should the output be if I'm looking for the number 2? When it gets sorted, number 2 should be in index 1 because 1 will be in index 0. 2 is the next ascending number, so 2 will be in index 1. When we're looking for 7, even after this has been sorted, 7 will not be found. That will return -1. So let's go ahead, switch back over to VB, run our program, and run these 2 sets of test data, which we know should run perfectly. Now, when I say run perfectly, I don't mean because I wrote the code. I mean because we have already tested the code. I want to make that very clear. How many numbers do we want to enter? We want to enter 5. What's our test data? 1, 6, 2, 8, 10. We can see it has been sorted perfectly here, and they want us to look for the number 2. If we look for 2, it should output 1. And it does. It is found in index 1. Let's go ahead, let's run this, and let's do our second set of test data here. So we're going to do 5 numbers again. 1, 6, 2, 8, 10. We're going to be looking for the number 7. That should return -1. And it does. It has worked as intended because we tested all of our code earlier. So that's going to be it for question 1. Let's go ahead and move on to question 2 as we push through paper 4 and earn all the points. This question is going to require the use of the trees.txt file. Now in the exam, it's not going to remind you for question 2 that you got to use the trees.txt file. So where do you find that information? You're going to find it at the very beginning of the exam. You're going to see open the evidence document, evidence.doc. If you need a video on how to fill out your evidence document, on how to paste your code, I'll be more than happy to make a quick 1 to 2 minute video to show you how to paste your code in the evidence document. I'll make that before the May and June exam. If you are testing in October, November, and you need a video before that, then go ahead and post a comment below, and I'll make sure to make one for you showing you how to fill out your evidence document. But it's going to give you those generic directions, and then you're going to see one source file is used to answer, then the question number. In this case, question 2. Then they're going to tell you what the file is called, which is trees.txt. You should have access to this file before you begin your exam. You don't want to wait till you get to question 2 and then ask your examiner for the file. It needs to be on a flash drive so you can put it directly into the computer, or it needs to be saved on the computer itself. You should not be downloading the text file from a school website or a class website because you are not supposed to be online during the exam. But now we know we're using the text file for this question, we can go ahead and take a look at it. A computer program will store data about trees. The user can enter their requirements for a tree and a suitable tree will be selected. The program is written using object-oriented programming. This might as well be written. This program is written using a programming style that will earn you a lot of points on your paper 4 exam. Object-oriented programming is worth so many points, and if you feel extremely uncomfortable with object-oriented programming, I want you to know that is normal. It is normal to feel that way because you're programming differently than you ever have. But stick with it, be consistent, make sure you practice, and it will become a lot easier to understand. Like anything else, the more you practice, the more consistent you're going to be. The class tree stores data. So we have 5 attributes here. Tree name, how much it grows, height growth, its max height, its width. Evergreen is a string, not a Boolean value. Notice this yes and no as to whether or not it keeps its leaves. That is a string. How do I know that's a string? Because it's in quotes. So it's not a Boolean value. It could easily be a Boolean value, but because they tell us it's yes and no, we have to use a string. So those are the attributes or characters or characteristics or properties of each object. Now, we have our constructor, which initializes tree name, height growth, max height, max width, and evergreen to its parameter values. This means that when we create the object, we're going to be assigning values to each property or characteristic or attribute of the object. Notice down here, we don't have any set methods. And earlier this year, somebody said, how do I know whether or not I need set methods? Well, you don't have to guess. Cambridge will tell you exactly what you need. In this case, the constructor is setting all the values, so we do not need any set methods. If the constructor did not set any values, then we would need a set method for each value that it did not assign through its parameter. Because it assigns all those, no set methods are needed, and we have 5 get methods, 1 for each attribute. So let's go ahead and take a look at what we need to do for part 1 of this question. Write program code to declare the class tree and its constructor. Do not declare the other methods. Use the appropriate constructor for your programming language. All attributes must be private. So they tell you that. You're not using dim, you're using the word private. So let's switch over to VB and let's pick up these 4 points. So we're going to start with creating the class, public class. What did they want us to call it? They wanted us to call it tree. Now it's time to put in all those attributes. Remember, all the attributes must be private. Maybe they're going to tell us that on the exam, maybe they're not. If they don't, we still need to make it private. So the first one is tree name. That's a string. The next one we're going to do is height growth. That's going to be an integer. And we just keep making all of these private. They tell us what they want us to use. They also give us the data type. So we have max height, we have max width, that's another one, as integer. And the last one they give us is evergreen, and that is a string. So they give us all those data types. The next thing they want us to do for this question is create the constructor. In VB, it will always be public sub new. And that's so when we use the keyword new in creating an object, it calls this constructor. Now it mentions that the constructor is going to accept 5 parameters to set the values to these attributes we just created. So I'm going to do by val. I'm going to do tn as string for tree name. I'm going to do hg for height growth. That's going to be an integer here. I'm going to do by val again. mh as integer for max height. I'm going to do by val again. mw for max width. That is an integer. And then I'm going to do by val eg as string, and that is for evergreen. Because remember, evergreen is going to be a yes or a no. The last thing I need to do is go ahead and take these parameters and assign them to their appropriate characteristics of the object. So tree name, I'm going to set that equal to tn, that parameter value. For height growth, I'm going to make that the parameter hg. For max height, I'm going to get the max height a value of mh, that parameter. I'm going to do the same thing for max width, but I'm going to use the mw parameter. And then for evergreen, I'm going to set that to eg, that parameter. Now, when we create this object, we will need to pass 5 values to this constructor so it can assign these values to the characteristics of the object. Let's go ahead and take a look at the next part of the question. The get methods, get tree name, get growth, get max height, get max width, get evergreen, each return the relevant attribute. Write program code for the get methods. This is pretty easy. Let's swing over to VB and quickly pick up these 3 points. All right, here we go. So for the get methods public function, make sure you're inside your class. All of these get methods always start with the word get and then followed by the attribute name. So the first one is get tree name. No parameters, the data type. Tree name is a string. I write return tree name. Just like that, you have your function. Let's do the next 4 functions. They're all the same. They're all the same. It's only the attribute name that changes. So the next one is get height growth. No parameters. What is the data type that's going to be returned? That is an integer. Return height growth. That's all you need to do. Now remember, we said there are no set methods because all the values are being set by the constructor. So if you're wondering why do we have get methods but not set methods, that is because they're all being set by the constructor. Next one is max height. So we're going to do get max height. That is an integer as well. And then that's going to be return max height. The next one is max width. So public function get max width. That is an integer as well. And we're simply going to return max width. All right, perfect. And the last one that we need is evergreen. It is common practice to have a get method for all your attributes. So get evergreen, no parameter as string. That's the data type that is returned. Return evergreen. Just like that, we have all our get methods we need and an additional 3 points on the paper 4 exam. Let's go ahead and take a look at the next part of the question. The text file trees.txt stores data about 9 trees. So now it's time to use that txt file. The data in the file is stored in the following format: tree name, height growth each year, maximum height, maximum width, evergreen. That works out very nicely for us because our constructor we put in the same order. It's going to make things so much easier to keep track of what is what. So for example, beech, the tree is a beech. That's its name. It can grow 30 centimeters each year. It has a maximum height of 400. So once it hits that, it's going to stop growing. A maximum width of 200. It is not evergreen, meaning it loses its leaves. And it says no here. Now, all of that is on one row. And let's take a look at the rest of the question. The function read data creates an array of type tree. Reads the data from the file. Raises an exception if the file is not found. That's nothing new. That's a try-catch statement. Creates a new object of type tree for each tree in the file. Appends each object to the array. Then finally, it returns the array. So very interesting here. This is probably one of the hardest object-oriented programming parts of a question that I have seen. But don't worry, we're going to break it down. We're going to go through. But what we have to do is we need to separate the name. We need to separate how much it grows, its max height, max width, and whether or not it's evergreen, all from this one line. It's not on separate lines. It's all on one. So we got to isolate each of these. And we have words such as beach and no. Those are our strings. But we also have integers that we need to handle. So I'm going to show you how to split these into sections and convert them to integers or strings, whatever it may be. So let's go over back to VB and let's do this right now, creating that function, read data. So we're going to head to the top of our code. We're going to do imports system.io. Then what we're going to do is we're going to scroll down here. I'm going to put mine right under submain. I'm going to do function, and I'm going to call mine read data. Well, I'm calling it read data because that's what they told us. It doesn't accept any parameters, but it does return the tree data type. Now, when you put tree here, it's not returning one object, it's returning an array of objects. We simply put that set of parentheses that lets the computer know, hey, we're going to be returning an array of objects because we got 9 trees we have to deal with. The first thing we need to do is we need to create an array of those objects. So I'm going to call mine trees because that's more than one tree. I'm going to need 9 of those. So I guess I can do 8 because 0, 1, 2, 3, 4, 5, 6, 7, 8 are 9 trees. And that's going to be a tree data type. So there we go. That will work perfectly. The next thing we need to do is we need a file reader as stream reader. We're going to be reading that trees.txt file. The next thing we're going to need is, because each of them are in a single line, we're going to need our tree data. Now we do have 9 trees we're working with, and I need to keep each line separate because I can use a for loop and repeat the same code I'm going to be doing. When we read that from a file, it's all going to be a string. We're going to need to convert it from a string to integers, and we'll be able to do all that no problem. Then what we need to do is we need, let's see here, we'll say split data as a string, because what we have to do is split the data. So we're going to write a line of code. I'm going to show you how to use the split method, and then we'll use that with the array of strings that it creates to run our for loop and create our objects. So we have to open that file, and we always, anytime we're opening a file, we always want to have a try catch statement. And let's go ahead and handle the exception. Maybe the file's not found. So we're going to say file not found. Give an appropriate message in case we try to open the file and something happens and it can't be opened. And most likely it's going to be because the file's not found. So what we're going to do is we're going to do file reader equals new system.io.stream reader. We're reading that file. What is that file? Trees.txt with a capital T. Now there's a lot of stuff going on here. We know there are 9 lines in the file because there are 9 trees. And mention that specifically. So we can use a for loop. If we didn't know how many trees there were, we would need to keep doing it while we're not at the end of the file. But because Cambridge gave away how many lines there are, we can use a for loop. So I'm going to do for I equals 0. I typed in O. That's not 0 at all. 0 to 8. There we go. Now, if you are emitting index 0 and your tree data and your tree object array is 9, you're going to run your for loop 1 to 9. When I do I equals 0, that doesn't have anything to do with the file reader when I'm reading that line. There's no line 0, line 1. It just knows it's going to loop a total of 9 times, starting at 0 and going to 8. So if you're wondering, is the first line always line 0? That has nothing to do with my 0 to 8. So just letting you know why I'm going 0 to 8. So what we're going to do is we're going to do tree data I equals, and that's going to be file reader dot read line. There we go, just like that. That will loop through 9 times, and it will fill tree data. It'll fill that array because I'm going to need to access that array because I'm going to need to split that object. Now, if you've done any splitting before, you may be saying, split data, we need to do something with that. Don't worry, I'm going to address that. I want to make it as easy as possible to understand, so I will be addressing that. Make sure you close the file. If something inadvertently happens to your TXT file during the exam, please let your examiner know that you need a new copy. So if you're trying to, if you're investigating the TXT file and you happen to actually alter something, that could change the entire thing. So if you feel like you have accidentally altered your TXT file in any way, just go ahead and ask your examiner for a new one. The next thing we need to do, now that we've loaded this tree data, is actually use the split method that is built in. There's lots of ways, I'm sure there are lots of ways to do this. The way that I figured it out was to use the split method. So let's go ahead and move on to that. Because the split data creates, or when we use the split method, and it creates a subarray of characters from the string, we need to make the split data an array. But I can't put a number inside these parentheses because then I have to access a specific index. Well, don't worry about declaring the size, because when you use the split method, the computer will go ahead and allocate the right amount of memory to be used with the array. Let me show you what I mean. Split data. If I have a number inside these parentheses, I have to identify the index. I don't want to identify the index. It does create a subarray of strings based on the string that we have, or the characters, or whatever it may be, and it will store it inside index 0, then 1, then 2, then 3, then 4. How do I know that? Because we know there are 5 attributes for each object. So my split data, what am I splitting? Well, that's going to be my tree data I dot split. I'm using that split method. How do I want to separate each thing in that one line? I want to do it with a comma. That is the parameter it takes. Now, we do need this to go 0 to 8. So for I equals 0 to 8. And then that will allow us to do it over and over and over again, because I'm not going to type this out 8 times. That would be a nightmare. Use your loops, make life easier for you. Now, my trees, I'm going to start at 0. I want that to be a new tree. Now, when I do a new tree, you'll notice there's a red line here. That's because we have 5 parameters we need to pass. Well, where are my parameters? They're inside this split data array. So I'm going to do split data, and all I'm going to do is access that array, 0. That is first because I know inside, or the very first thing of that line is the name. The next thing I'm going to do is I'm going to do split data. Now the next one is actually an integer, so we actually need to parse it. So integer.parse. What this means is we're going to take a string, we're going to convert it to an integer. I can't leave it as a string because in my parameter it says how much it grows, or height growing as integer. So I can't pass a string because integer and strings, they're not compatible. So all I do is integer.parse. What am I trying to parse? Well, that's going to be my split data 1. Then I need to do the next integer. Not that at all. So let me try that again. So that's going to be integer.parse. There we go. And that's going to be split data, what index? 2. Then, let me move this line over so we can see the rest of them. What about the third characteristic? That is also an integer. So I'm just going to keep using integer.parse. I'm converting these string numbers to actual integers. That is split data 3. Now, the last one, split the fourth index, that's a string. So all I'm going to do is I'm going to do split data 4. I don't have to parse that because it's already a string. Let's see here. That looks like enough. So let's see here. It says argument not specified. So we have 1, 2. Saying the second one. Did we not make the second one an integer? Let's take a look here. It's an integer. So that means 1 is off somewhere. So it says +3 overloads. So we're doing, right here. Okay, so it's simply a parentheses. I'm trying to parse the whole thing here. There we go. So it's just a parentheses out of whack. So when you're on your paper 4 exam, and this is why I stress all the time, it's so important you understand your data. It's so important, or your code. That way you can fix it when you run into an error. So that's it. All we need to do now is we need to return that array. So I'm going to return my trees. You don't need to put any parentheses there, and it will return the trees, that whole object array. Let's go ahead and take a look at the next part of the question. All right, for part C, the procedure print trees takes a tree object as a parameter and outputs the tree's name, height, growth each year, maximum height, maximum width, and whether it is evergreen. The output message changes depending on whether it is evergreen. If it's evergreen, we say tree name has a maximum height. All the other attributes, it does not lose its leaves. So we definitely want to use that string specifically that it gives us. If it's not evergreen, it says it loses its leaves each year. So it's based on whether or not it's evergreen. So we're going to write program code for print trees, that procedure, and we're going to pass down the tree object. So we're going to go ahead and do that right now. And it should accept any tree object that is passed down. We'll switch over to VB and code that out. All right, so we're going to go ahead and create that procedure sub print tree. Now my parameter, I'm going to call O tree for object tree, and that's of tree data. Nothing outside the parentheses because it's not returning any data. I'm going to do dim leaves as string. Now, the leaves refers to whether or not it loses its leaves. So all we have to do is we're going to do that O tree dot, and we're going to get that evergreen, which is going to return either yes or no. If it equals yes, then what we are going to do is we're going to set leaves equal to it does not lose its leaves. That's what they wanted us to use. If it doesn't equal yes, it's got to equal no. So leaves will be it does lose, or it loses, that's what they wanted. It loses its leaves each year. So we want to use the string they give us. It shows us the format they want it to be in. All we need to do now is we need to output each attribute of the object by using those get methods in this console.write line. So the first thing up is the tree name. So I'm going to do O tree. How do I get its name? I'm going to use that get name, get tree name method that we had. And then I want to use that format they gave us. Has a maximum height, and then it wants us to use or display the maximum height. Well, that's going to be O tree, and all I'm going to do is get that max height method that we did. Let me move this line over so we can see the rest of it. After the maximum height, the next thing it needs to give us is the maximum, or we need to show is the maximum width. So max width, and it's just maximum, or is it? Yeah, it's maximum. So let's use the whole thing they gave us. Maximum width. All I'm going to do is my otree dot get max width. That's all we're going to do is we're going to use those get methods so we can do it. After we do the maximum width, we need how much it grows. So we're going to get that growth. So, and it grows. And then that's otree dot get get tree, get growth. What did we call it? Let's see here. We called it, get height growth is what we called it. So let's just come down here and we'll fix that. No big issue there. We just need to know what's called get height growth. There it is. And then all we need to say how many centimeters a year, and then we need to output the final, which is leaves. We'll put a period here, then we'll do leaves. And just like that, it will print whether or not it loses its leaves. That is the print tree procedure, accepts the object as the tree data. We check to see if it's yes or no, which gives us the leaves. We print the tree name. We say it has a maximum height of the otree.getMaxHeight. The width, using that getting max width get method. Then we get the height growth, and then the leaves, whether it loses its leaves every year or not. So let's go ahead and take a look at the next part of the question and get ready to wrap this up. And moving on to part D, the main program calls read data, stores a return value, and calls print trees with the first object in the returned array. Write program code for the main program, test your program, take a screenshot of the outputs. So what we want to do when they're talking about the main program, that's submain. So let's switch over to our submain and code this out. All right, so we need to create an array of objects. I'm going to call mine all trees. It's going to have a maximum index of 8 because there are 9 trees. What data type is that? Tree. Anytime you're creating an array of objects, you want to omit the keyword new. If I put new tree, it's not going to allow it to do it. Now, all trees, I don't need to reference an index here because remember, our read data, it reads the file and returns an entire array. So I can just do all trees equal read data. The next thing I need to do is print the tree, and I need to pass down the first index. Well, what's the first index of my all trees? That's going to be index 0. So I'm going to save. Now it should, let's see what it outputs here. Now you want to be testing your code. Yep, that's what I'm looking for. Beach has a maximum height of 400, width 200, grows 30 centimeters a year. I don't like not having a space between this period and it. It loses its leaves each year. That is true because it's not evergreen. So what I'm going to do is I'm going to scroll down to that output. I'm going to scroll over to the right here, and it grows centimeters a year. I'm going to put that space so it says it loses its leaves each year. So the code is working perfectly. That's great. Let's move on to the next part of the question. The procedure choose tree takes an array of tree objects as a parameter. So we're going to pass down a whole array of objects. The procedure prompts the user to input their requirements for a tree. The user needs to enter the max height, width, whether they want the tree to be evergreen or not. A tree meets the requirements if a tree's max height is not more than the user's input, and the tree's max width is not more than the user's input, and the tree matches their evergreen input. So we're giving the user a certain amount of options for a tree, it looks like. Now, there could be a total of 9 trees that we give them as options. The procedure creates a new array of all the tree objects that meet all the requirements. So there it is right there. We're going to create a new array of objects that meet the user's requirements. If there are no trees that meet all the requirements, a suitable message is output. Write program code for choose trees. So let's swing over to VB and let's give a user all these options based on their criteria. All right, so here's our sub choose tree method. I've passed an array by ref. Trees is the name of my array. How does the computer know it's an array? How do I tell it? By putting a set of parentheses. What's that data type? It's a tree. Now I have max height, max width, and choice. I want to get the criteria from the user. So I simply ask them, what do you want the max height to be? What do you want the max width to be? Do you want it to be evergreen? Notice I've indicated whether they should do yes or no with a capital letter. Now they want us to build a brand new array of objects. So we're giving the user a set of options. So I called my array options, max index of 8 because there are up to 9 trees here. Then we have dim index as integer. That is going to help control where we are. Once we have a criteria that meets their choice, I'm going to increment index to go to the next spot of the array. So I'm going to do for I equals 0 to 8 because I got to check all those trees. Now, if the max height that the user entered is greater than or equal to my trees I, the first one, index 0, get max height. And this is why object-oriented programming is great. You have these get methods that you can just use over and over and over again. And our max width is greater than or equal to the trees I dot, we're going to get its max width to make sure it matches. And choice equals, let me move this arrow over so we can see it, and choice equals trees I dot get evergreen. Because remember, that's going to return a yes or no. Then what do we want to do? Well, then what we want to do is we want to record that tree into our options array. That's what we want to do, because if it matches, we want to put it in there. So all I'm going to do is I'm going to do options with my current index, whatever it is, and all I have to do is do trees I. Because this is an object, and this is an object, I can take that data and simply put it into options inside that index. I'm going to increase index by 1. I don't have to do all the things independently. I don't have to do all the attributes independently. I can't even do it all independently because we don't have any set methods. So when I do options index, I'm going to take the data of my object, put it right into this index of the objects itself. The next thing I need to do is I need to print those trees. So I'm going to print my tree. Now this will only accept 1, so I got to make sure I do it inside my for loop here. So I'm going to print my tree, and then my print tree. What am I passing? I'm passing tree I, or options index. It doesn't matter which one you really pass because you'll be able to do it, and that's trees. There we go. All right, the next thing we need to do, we need to see if index equals 0, then we're going to let them know there are no trees for you. The next thing we need to do is update submain so we can actually call this method. Let's do that now. All right, inside our submain, all we're going to do is choose tree. Now we need to pass down that entire array, all trees. You don't need to put it in parentheses. It already knows that all trees is an array, and it's set up to accept an array. All we got to do now, let's run our program. Let's go ahead and test our code. They may have us run it in a minute anyway, but let's go ahead and test our code. Let's make sure it works. Let's not wait until we get to that question. Let's test it now while it's fresh and make sure we have it. What do you want that max height to be? Let's make it 500. That's as tall as I want it to go. What do you want the max width to be? I want the max width to be at least, or at most 300. And then, do I want an evergreen tree? No. So let's see how many options that gives us. So it says beech has a maximum height of 400. Great. That meets my criteria. Maximum width of 200. That meets my criteria. And it loses its leaves each year. Perfect. Hazel has a maximum height of 300. That meets my criteria. 200. That meets my criteria. And it loses its leaves each year. Let's go ahead and run it again. And this time, let's say yes. So let's say we want a max height of, let's get more trees, 700. We'll say a max width of 700, and we'll say yes. Are there any trees that meet our criteria? Let's hit enter and see. Oh my, we have 1, 2, 3, 4, 5, lots of trees to choose from. We can see that the max height and width for all these trees match our criteria, and that it is evergreen because it does not lose its leaves. So that is working perfectly. Let's go ahead and take a look at the next question and see what they want us to do. The procedure choose tree needs amending. So after all that work of putting it together, they want us to update it. After the procedure has output the list of trees that meet all the requirements, the procedure needs to take as input the name of one of the trees that the user would like to buy from those that meet all the requirements. Okay, so that's not that hard to do because each name is unique. Take as input the height of the tree in centimeters when it's bought. So that is how tall it currently is, and we know how tall it is because that's how much it grows each year. Calculate and output how many years it will take the tree to grow to its maximum height. For example, the user inputs the tree beech. The tree's height is 40 centimeters when bought. It will take 12 years to reach its maximum height of 400 centimeters. Write program code to amend choose tree. Well, we know choose tree works. That's great that we tested our code. Let's go ahead and amend it so the user can actually choose a tree, and then let's let them know how many years it's going to take to reach its full height. I like to keep my variables organized. So what we're going to do is we're going to do valid as Boolean, because maybe they're going to try to be sneaky and try to enter something that doesn't exist, something that's not an option. We want to make sure they make a valid input. The next thing we're going to need is we need that starting height. So I'm going to do start h as integer, because I need to know what do you want the starting height to be, and then the years, how long it's going to take to grow. I'm going to do that as a decimal, and what we'll do is we'll round it for them. So let's go ahead and come down here, right underneath here. Now, what we need to do here is if index equals 0, we need to exit the sub. If we do not exit the sub, then all the next questions that are going to be asked are going to run. Another option is to put it right here after this for loop. It doesn't matter how you do it. I'm going to put it before this, or right after this for loop, before this if statement, so I can get rid of this exit sub. But that is an option too. So if you're wondering, where do I put it inside this method, this procedure, you can do it either right after the for loop or after this if statement. But if you're going to do it after this if statement, you need this exit sub so it exits and doesn't run the rest of the code. So what we're going to do is we're going to ask them. So we're going to loop until valid equals true. Now, before we go in here, we're going to set valid equal to false because we don't know if they're going to make a valid choice or not. So we're going to keep looping this until valid equals true. Now, what we're going to do is we need to go through every single one of those options to see if it matches what they want. Let's see here. We didn't even get the name. So let's do dim name as string because we need to ask them what name, what type of tree do they want? And they'll tell us from the list of options that are printed. So we're going to do, let's see here. We need to ask them console.writeLine what tree do you want? And then we're going to store that in name. Now, once we get the name, all we need to do now is we need to loop through all the options that we currently have and see if it matches what they have. So we're going to do for I equals 0 to 8 because we want to loop through all those options. And all we're going to do is we're going to do if options I dot get tree name is equal to name. Then we know they have made a choice. So our valid equals true. That way they don't get asked again because we want to check that at the end. And then what we're going to do is we're going to ask them, okay, what do you want the starting height to be? So this if statement is going to be pretty big here because we only want to ask them what they want the starting height to be if it matches one of the options. So we're going to do what do you want the start height to be? So then we're going to do start h equals console.readLine. Do a little bit of math here, get the computer to do a little bit of math because we need to figure out the years. So for the years, what we need to do is we need to do options I. We want to get the max height. What we need to do is we need to subtract that from what the starting height would be. Because if it starts at 100 centimeters and its max height, say, is 400 centimeters, we don't need for it to wait to grow 400 centimeters. We want to subtract the starting height. And then what we're going to do is we're going to divide that by the options I dot get height growth is what they called it. So that's what we need to do. That will give us the years, and then all we're going to do is do console.writeLine. Your tree will grow to full height in about, and then we're going to do our ampersand. We're going to do years, and then we'll say years, just like that. So our console.writeLine, your tree will grow to full height in about years and years. Now, if you want to make this, efficient, exit the for. Exit the for loop. It'll loop until valid equals true, and then this is only going to run. This for loop's only going to run if they make a valid choice. Once we exit the for loop, we're going to loop until valid equals true. This if index will not run. So with that, we're good to go. We can't just put exit sub because if it never meets the criteria, then it'll never say there are no trees for you. That should do everything. Let's take a look at the last part of the question and wrap this question up. All right, write program code to amend the main program to call choose trees. So everything we just wrote, it's about to test it. Test your program with the following tree requirements: maximum height of 400 centimeters, maximum width of 200, and a tree that is evergreen. So when it asks us, do we want it to be evergreen, we're going to enter yes. When asked for the tree selection, we need to enter the blue conifer, and that should be one of the options that we get with the starting height of 100. So let's swing over to VB. Let's call choose tree. Actually, we've already called choose trees. We can run it again. We're going to enter these requirements. Hopefully, well, we should get the blue conifer tree, and we'll see that it reaches its maximum height. So let's go ahead and switch over. Okay, here we go. So what do you want the maximum height to be? They said to enter 400, the max width 200. Do we want it to be evergreen? Yes, we do. There it is. The blue conifer is an option. That is perfect. Has a maximum height of 250, which meets our criteria. Maximum width of 50 meets our criteria, and grows 40 centimeters a year, does not lose its leaves. What tree do you want? Now, if we enter the blue conifer, if it grows 40 centimeters a year and we start it at 100, it should be about approximately 3.75 years, roughly somewhere around there. And yes, it does. So your tree will grow to full height in about 3.75 years. So that's going to wrap up the object-oriented programming question. Let's move on to the next question in the paper 4 exam. And we have finally reached the last question on our full paper 4 walkthrough. So a program reads data from the user and stores the data that is valid in a linear queue. So for this last question on the paper 4 exam, they had an abstract data type, specifically the queue. The queue is stored as a global 1D array called queue data of string values. Now the array needs space for 20 elements. Now because it says it needs space for 20 elements, if I start at index 0, which I'm going to do, I need to go all the way to index 19. That will give me space for 20 different elements. The global variable queueHead stores the index of the first element in the queue, while queueTail stores the index of the last element in the queue. So the queueHead shows us where it begins, queueTail shows us where it ends. It does not start at index 0. If it started at index 0, I would have one item in my queue. It is not starting there though. So where is it starting? Well, let's take a look. The main program, that is public submain, initializes all the elements in queue data to a suitable null value, the queueHead to -1 and the queueTail to -1. And the reason both of those are set to -1 is because the queue is empty. Nothing has been added yet. So let's swing over to vb.net and let's pick up this point. So we're over here in the VB, so let's go ahead and do queue data. That's going to be an array. Now I'm going to do -19 because I'm going to start with my index 0. We also need to do the queueHead, and that is going to be an integer because it points to the index where the queue starts, and then the queueTail as an integer to point to where it ends. Now it says we need to initialize those. So the queueHead, there it is. queueHead is going to be equal to -1. The queueTail is also equal to -1. And then what we need to do is we need to set the queue data array to a suitable null value. So I'm going to do for I equals 0 to 19. And all I'm going to do is queue data I equals right there. And just like that, we're done. It's very important you don't put a space here. Space does have an ASCII code value, but if we put in nothing between the quotes, there is nothing there, and that is a suitable null value. Let's take a look at the next part of the question. So part B is going to add functionality to our queue. We're going to have the function enqueue, which takes the data to insert into the queue as a parameter. Now remember, queues work on the first in, first out principle. It works just like a queue line does at a theme park. The first person in line is going to be the first person to leave the line and get on the ride. Now, if the queue is not full, it's going to insert the parameter into the queue. We're going to update the appropriate pointers and return true. If the queue is full, it returns false. Now, what does it mean by appropriate pointers? That's the queueHead and the QTel. Once we add our item to the queue, they're no longer going to be -1. I'll show you what they are when we code this out. For part C, we're going to do this at the same time. If there's a way to add an item to the queue, there must be a way to see the first item that's going to leave the queue, and we call that DQ. The function DQ returns false if the queue is empty. Now, this is not the same false as the false up here. This true and false refer to a Boolean value. I know that because they're in all caps and there are no quotes around it. Down here, this false, all lowercase, and it's in quotes. That means it's going to be a string, so you want to be on the lookout for that. If the queue is not empty, it returns the next item in the queue and updates the appropriate pointers. So you may be saying, why did they make this one true and false a standard Boolean value, and why did they make this one a string? Are they trying to trick us? And the answer is no. Remember, the queue data that we have that stores the 20 elements, what data type is it? It's a string. And if the queue is not empty, it's going to return the next item in the queue. Well, in order to return the next item in the queue, it needs to return a string data type. So that's why they have it set up that way. So let's write program code for enqueue and dequeue over in VB.NET right now. All right, we're going to start with the function enqueue, adding things to the queue. We're going to do data as string. That's what's going to be coming down. That's the parameter. It's going to return a Boolean value. It returns either true or false. Now, one of the things that can happen is the queue is full. So we need to check that QTel, see if it equals 19. If it does, then that means there is no more room, because where does the queue end? It ends at index 19. I don't have anything larger than that. So what I'm going to do is I'm not going to do anything other than return false. Now there's another thing we need to account for, and that's if the queue head equals -1. If it does, then what we need to do is we need to increase it to 0. That's what we need to do. Now, those are the two possibilities we need to account for. When we add an item to the queue, it's not the queue head that always increases. That's showing me where I start. We update the queue head when we actually remove an item from the queue. When we're adding an item, we need to update the QTel. So all I'm going to do is I'm going to do my QTel plus equals 1. That's going to show the next item. So if I have an item in index 0, well, then I know the queue head was -1. I set it to 0. But when I add another item, the queue head is no longer at -1. It's at 0. But that's okay because it's still starting here at 0. But where's the next item going? That's going where the QTel is. But in order to do that, I need to increment the QTel. So now that I've incremented the QTel, I can use it. So QData, QTel, that index, what am I putting in that? I'm putting data, and then all I'm doing is I'm returning true. So let me say this again. After we come out of this if statement, if there's room in the queue, then we're going to increment the QTel. I want to make sure I do that so it goes in the right spot. If I do this first and then increment QTel, it's going to overwrite the item that was pre-existing in the queue. Now that we have that, we can do the function dequeue. So we type in that function dequeue, and we're going to do, no parameters here, but it does return a string. So that's very important. Now there's one possibility. Before we even can try to, or there's multiple possibilities, before we try to remove something from the queue, we need to see if there's anything there. And if my queue head is equal to -1, then I know the queue is empty. Another possibility is that we've removed everything from the queue already. So if my QTel equals 20, then I know I've removed every item from the queue. Another possibility is that the queue never got full, but I still removed all the items. And that is in any case where the queue head is greater than the QTel. If that happens, then what we are going to do is we are going to return false, but this time the false is going to be in quotes. So if that doesn't happen, then what we need to do is we need to update the queue head, and then we need to return the data. Now, here's what we need to do. We cannot do returning the data first. When you're in a function and you hit a return statement, none of the other code inside that function is executed. It immediately goes back to where the function call happened. So what we need to do is we need to update the queue head first. But that can bring up a slight issue, which we'll address in just a moment. If the queue head has been incremented by 1, that means it's skipping over the item that's supposed to be returned, because I need to return that item. So queue data, queue head. But that's not where the item is because I just incremented it by 1. How do I get back to the item before it's incremented by 1? I'm simply going to -1. That's all we need to do. The queue head increments, so when I add my first item, the index becomes 0. I increment queue head by 1. So the queue head is now 1, but what am I returning? I'm returning the index previous to index 1, which is 1 minus 1, which is index 0. But now, because it's been removed, and it's not really being removed from the array, what we've done is we've left it in the array, but we moved the queue head to the next starting point. So now, because the queue head is pointing to 1, we know that index 0 will never be accessed again. If we try to dequeue it again, because we still have an item in there if index 1 is being used, we removed index 0. If we dequeue index 1, queue head increments to 2. Now the queue head, we are returning the queue data of 2 minus 1, which is returning index 1. Because we updated the queue head, if we tried to dequeue anything else, well, now the queue head is 2, the queue tail is 1. 2 is greater than 1, so it's simply going to return false, and that's it for the enqueue and dequeue. Let's go ahead and move on to the next part of the question. So you open your test booklet, you get to D, and it looks like a lot. You start to feel overwhelmed. Don't. Remember this. You are awesome, and you can do this. This is nothing that you can't handle. Remember, you're an A-level student. You've made it all the way to paper 4. You can do this, so just take a deep breath, relax, and remember, you got this. The string values to be stored in the queue are 7 characters long. Nothing you can't handle. The first 6 characters are digits, and the 7th character is a check digit. Again, nothing you can't handle. The check digit is calculated from the first 6 digits using this algorithm. You've been writing algorithms since pre-8s. Here they've given you one. All we got to do is follow those directions. Multiply the digits in position 0, 2, and 4 by 1. Or if you want to make life easy on yourself, don't multiply them by 1 at all. Just leave them alone and add them onto the total. Multiply the digits in position 1, 3, and 5 by 3. Calculate the sum of the products. So add together the results from all of the multiplications together. Then divide the sum of the products by 10. Round the result down to the nearest integer to get the check digit. If the check digit equals 10, it's replaced with X. If you are using VB.net, you need to perform integer division. If you do not perform integer division and you do regular division, and that result that you're calculating comes out is declared as an integer, which it will be because we're looking at whole numbers here, it will round to the nearest whole number. It won't always round up. It will not always round down. Here's an example. 7.5. It rounds to 8. Why does it round to 8? Because 8 is the nearest whole even integer to 7.5. So 7.5 rounds up to 8. What about 6.5? 6.5 rounds down to 6 because 6 is the nearest whole even integer. So when we perform division on this, we're going to be using integer division. So we're going to be flipping that division sign around. So here they give us an example. 954,123. So it runs it through this algorithm. It gets the check digit as 4. That is inserted into position 6. A 7-character string is valid if the 7th character matches the check digit. So we would enter 954,123,4. When we hit enter, it will then run the algorithm and calculate the check digit. We'll need to see if the check digit matches this character. If it does, we know that it is a valid set of data. The data, 954,123,5, is invalid because the 7th character 5 doesn't match the check digit 4. If I do 954 1 2 3 5, I know that's not valid because when I run 954 1 2 3 through this algorithm, we know the check digit is 4. It's because 5 in this example does not match 4. We know it is not valid. So what do they want us to do with this? Well, the subroutine store items takes 10 7-character strings as input from the user and uses the check digit to validate each input. Each valid input has a check digit removed and is stored in the queue using enqueue. So what we want to do is we have that 7-character string. We check to see if it's valid. If it is valid, meaning the 7th character matches the check digit, we're going to cut it off, and then we're only going to insert into the queue those 6 characters. We're not including the check digit because it says the check digit is removed and is stored in the queue. The valid input is stored in the queue. So that 6-character string. An appropriate message is output if the item is inserted. An appropriate message is output if the queue is already full. Invalid inputs are not stored in the queue. The subroutine counts and outputs the number of invalid items that were entered. Store items can be a procedure or a function as appropriate. Write program code for store items. So let's swing over to VB.net and handle that right now. So let's take a look at the code I have structured so far. Here we have substore items, input as string. This is for the 7-character string that we're going to have to enter 10 different times. Total. Total is going to be, so when we perform the algorithm, we're going to get the total. We're going to need to perform integer division, dividing by 10. Result. Remember, when we try to add something to the queue, it's going to return a Boolean value, either true or false. So we need to check to see if the result is true. If it's true, then we need to output a message saying, hey, we added that item to the queue. If it's not true, we're going to say we can't. The queue is already full. And then invalid, where you need to keep track of how many invalid entries there were. It says specifically to count how many invalid entries there were and to output those. So here I have my for loop, my outer for loop. Get rid of this space here. For I equals 1 to 10. Why is it 1 to 10? Because I want to input the 7-character string 10 different times. Now, I only need to keep track of the most recent one. I don't need to put this in an array because once I get the input, I can go ahead and perform the conversion of the string to characters. Now, remember, in position 0, 2, and 4, I don't need to do anything. I don't need to perform any math. All I need to do is simply add it on to the total. So here I have an inner loop that runs through the first 6 characters of the string 0 to 5. And I'm using substring, which starts at 0. Now, if j mod 2, I can't use I is already being used because I have an inner for loop here handling the algorithm. I got to use j. So j equals 0 to 5. If j mod 2 equals 0, so when j is 0, modding by 2, that becomes 0. When j is 2, mod 2, that becomes 0. When j is 4 mod 2, that is also 0. Well, what am I doing? I'm simply taking the integer of that string and adding it on to the total. How do I convert that character or that string number to an actual integer? Well, I use integer.parse, which means I'm converting a string numerical value to its actual integer numerical value. So integer.parse, what am I parsing? Input, that is my string. What value am I doing? Wherever j is, and I want 1 character from that point. Now, if I mod it by 2 and it's not 0, then I know I'm at position 1, 3, and 5. What's the rule for that? I'm going to do total plus equals integer.parse. Then I'm going to do the same thing here. Whatever j is, I want 1 character, but I'm going to multiply it by 3. The next thing I need to do is I need to do divide equal by 10. Notice we do not have this division sign. We have this division sign. Now that we have that, we can start checking to see if we can add it to the queue and if it was successful. It's still inside my outer for loop. This inner for loop performs the algorithm. The outer loop is going to handle the 7-character string and then finding out, hey, can we add it or not? So we got to check to see if the check digit matches the actual check digit. All right, here we go. So all we're going to do now is we need to run some if statements. One possibility is that total equals 10. What was the rule if it comes out to 10? Then we got to see the check digit should be an X. So if total equals 10 and our input dot substring, and what I want to do is I want to start at character 6. I want to extract one character. Then it's valid and we want to try to add it to the queue. Remember, result is going to hold a true or false value because when I call in queue, it's going to return true or false. But what am I passing to the in queue? Well, I'm passing my input dot substring. I want to start at character 0 and I want to extract the first 6 characters. So that is character 0 or character 0, character 1, character 2, character 3, character 4, and the 6th character would be character 5. We are not including the check digit. So that's why we have that. So character 0 or position 0, 1, 2, 3, 4, 5. The check digit is in position 6. This 6, you can think of it as exclusive if you want, but we're starting at 0 and we are extracting 6 characters starting from position 0. Here it doesn't make sense that you would start at 6 in that 1. So you're starting at position 6, you're extracting 1 character. So that's how you want to think of that. Now the result is either going to be true or false. If result equals true, then what we want to do is we want to output a message, item added to the queue. Now if it's not true, we know it's false, and we output an appropriate message. The queue is full because we know it's going to return true or false. So the queue is full or item was added to the queue. So that is one possibility. We want to go outside this if statement here. The next thing we need to do is there's an else if. The other possibility is that total is equal to the check digit in the string. So we got to use that integer.parse again, because when we parse it, it doesn't actually take it and just convert the whole thing to an integer. So what are we parsing? Well, what we need to do is we need to do the check digit. So that's going to be input dot substring. Where is that character? That's located, the check digit is located in character 6. We want to extract 1 character. If it is equal, then we know it's valid. We need to add it to the queue. Result equals in queue input dot substring. And what I want to do is I want to start at character 0. I want to give it the first 6 characters, which is position 0, 1, 2, 3, 4, and 5. So you definitely want to be on the lookout for that. And then all we got to do is if result equals true, we're going to output that appropriate message, console.writeLine, and we're going to say item added to the queue, because I want it to say the same message. And then we're going to do else. And then what we're going to do is the same message again. The queue is full. That way, no matter whether it's the X or the check digit that we're adding, it will do it. Now, so one possibility is if it's 10. Oh, here, almost forgot this. If input substring character 6, if we start there and we get 1, if it equals X. Ooh, almost forgot that. That was that's extremely important. Otherwise, our code wouldn't work. The other one is total equals the actual or the check digit in the string. The other possibility is that it doesn't match. So we're going to do this else statement here, and we're going to do invalid plus equals 1. Then what we're going to do after all of these run, we're going to output how many invalid strings there were. How much invalid data. There were invalid, so there were like 6 pieces of data. So that will output how many is invalid. Now, there's one line of code that is extremely important. Before you enter the second string, so before this loop goes back up here, to the outer loop, you need to reset total to 0. If you do not, it'll work the first time and only the first time. If you do not reset total equal to 0, what is going to happen is you're going to be adding the total across all 10 7-character strings. We don't want to do that. The check digit doesn't include any previous strings that we entered, only the current string that we are entering. It looks like a lot, and it is a lot, but all we're doing is breaking it down. If you would like to, in this for I equals 1 to 10, if you want to do total equals and parse character 0, character 1, character 2, 3, 4, and 5, multiplying the odd ones by 3 and just extracting the even positions, you can do that. That's a lot to type out. I like to get the computer to do most of the work for me. Again, we are using integer division here. We are dividing it by 10, and that's going to chop the decimal off, preventing it from rounding to the nearest whole even integer. We're checking to see if that result is 10. If it is, and that check digit is an X, we're going to add it to the queue. This in queue returns either true or false. If it returns true, then we know the item was added. If it returns false, then we know the queue is full. The other possibility is that we don't get 10. We get another single digit number. We're checking to see that it's equal to whatever that check digit is. If so, then we need to try to add it to the queue. If we were able to add it to the queue, we simply output the appropriate message. If it was unsuccessful, we say the queue is full. If it doesn't match the X in 10, doesn't match the check digit we calculated with the check digit in the string, then we know it is invalid. We increment that by 1. We reset total to 0 so we can input the next string and calculate the right total. At the end of all 10 strings, we say how many were invalid. So with that done, let's take a look at the next part of the question and start wrapping this up. Write program code to amend the main program to call store items, call DQ, output a suitable message if the queue was empty, output the return value if the queue was not empty. So we're going to go ahead and do that. Then what we're going to do is we're going to test the program with the following inputs in the order given, and then we're going to go over and make sure it is correct, running it through the store items that we just talked about. So let's go ahead and wrap up this paper 4 exam. So we need to call store items. So we call store items just like that. We're done. Now DQ, we need an item as string because we're going to try to remove an item from the array. Now when I say remove, what I actually mean is leave it in the array but update the head pointer. So we're going to do we're going to do item equals to queue because that's going to return false or the actual item. And when I say false, I mean false in quotes. So if item equals false in quotes, then we're going to output a message. There are no items to pull from the queue. Then if it doesn't equal false, then we know there's an actual item. So all we're going to do is we're going to say the item is, we're going to put a space, and then we're going to do the item. This will call store items, and this will call the DQ method that they want outputting the appropriate message. What we need to do now is we need to enter those sets of data. So we're going to start our program, run that set of data, all those 10 strings, enter all of them, and make sure that this program works. So we need to input the 7-character string. That's going to be 999-999-X. Now that should work. Now it should say item was inserted, item added to the queue. Perfect. Now, because that's the first item added to the queue, and we only call DQ once, that is the item it should pop, except for it should be without the X because we're not adding the check digit to the queue. So it should output 999-999. That's what the item should be because it was the first one added to the queue. All right, let's do our next set of test data. I'm reading this straight from the test data they gave us, 1251484. Now this one should also work. Yes, perfect. Added to the queue. Now we need to do the next one. This is going to be 5500 212. This one should also work. Perfect. Okay, now that's either good news or bad news. That means everything's being added to the queue, or it's working as intended. This next one will tell us. So we're going to do 0033585. Now, this one should not be added to the queue. This is going to bring the invalid count to 1. Perfect. We don't see that the item was added to the queue. That's because it's invalid. Perfect. Next one, 984, and then that is 5788. Okay, this one should work. Perfect. Item added to the queue. The next one is all sixes. 1, 2, 3, 4, 5, 6, 7. Okay, all sixes. That should not work. Perfect. We're not getting that message saying item was added to the queue. The next one should also not work. This is 3, 2, 5, 8, 7, 4, 6. So I went through and checked all of these, figured out which ones should work, which ones should not work. So this one should not work either. Perfect. It doesn't. That brings the invalid count to 3. Now what we need to do is enter 811122. That one should, that one should work. Perfect. Item added to the queue. Okay, the next one, 756 8557. Now, when you're entering these, you want to do them correctly. If you enter one wrong, you got to start all the way back from the beginning. So I'm double checking what I entered here. This one should work. Perfect. This last one should not work. And then we should see that the item is 6 nines in a row. So 999999. So I'm going to enter 00, 1, 2, 3, 5, 3. That should not work. There should be 4 invalid items, and we should see all 9s. And there were 4 pieces of data that were invalid, so we would go back. Well, let's go back and fix it now. Let's go right back now and fix it. There were 4 pieces of data that were invalid. Cambridge can be a little picky at times, so if you say there were 4 pieces, they may or may not give it to you, but by doing that, you're good to go. We got all 9s. This is probably one of the hardest paper 4 papers I've seen in a while. I talked to my students who returned this week. They said they didn't think it was that bad, so I'm glad they feel like they learned a lot. Hopefully you learned a lot in this video, or at least picked up something new that you didn't know before. If you found this video helpful, please consider leaving a thumbs up and subscribe to help the channel grow. If you have any questions, please post a comment below. Remember, you have made it all the way to A level. You have made it all the way to paper 4. You are doing what needs to be done to succeed. You are awesome, and you can do this. And we'll see you guys in the next programming video.